a kiln oven, of which is now coming up to temperature at about 1850 degrees, almost 1000 C. And of course what we're going to be doing is building a Prigogine crystal tonight for sound, which is how Tom Beard and I met. Tom Beard and I met through these unique crystals that I used for sound. And I'll just explain a few of the components, and then I'll get into the story with Tom. But we have what we call a substrate slab. And this is a material that we choose because of the copper content, but I would have liked to have done this with oxygen-free copper, but this is what I had available and nobody in town had real copper. So the base material, the same thing that you'd find in a transistor, we'd be using a substrate base. And then we're going to be adding our materials, which are rocks, because of the compounds in the rocks. And then we're going to be combining that with the powder that we grew here that you see on this rod. And we're going to put all this together.
And that was the Sajeka stuff, right?
Yes, this is a Sajeka process, but it's what Tom talked about with the Prigogine crystal. And we're going to be using this mortar and pestle to grind up our materials. And then we're going to be laying out a path in a crystal, and where we place these little dots. We're going to get our sound.
So these little dots are all different widths,
yeah,
or thicknesses.
Yeah, it's not going to make a difference because all we need is a connection.
Okay.
So they're very close. We'll pick the closest ones. But it's what I could get to do this demonstration, and you might say alchemy, but it's not. It's a very precise process, and we've used it for years. And this all comes from early on with John Sajeka. So what we're actually building here is a sound filter, and we're going to take the harshness out of the amplifier when we do this. Now this could be semi-conductive if we wanted it to be, but it's not going to be. It's going to just be used to move the sound around where we want, and then of course in the end we'll demonstrate that. But back to my story with Tom. I met Tom Bearden through these type of crystals, and I was fascinated by Tom's work, and he actually talked about, you know, building a stressful crystal in his book, in his very first book. And so I said, I think I'll give it a shot and see where this guy's at. And I sent him some crystals. Now, whether Tom hooked them up or not, I don't know. I have no idea. But he definitely got back to me in a hurry. And he says, that's amazing work. He said, you know, because the crystals that I sent him actually had little adjustable fingers, and you could had contact points where you could use it like a transistor if you wanted to. It was a very special transistor because it's made out of powder that's grown through the Sajeka process. And actually it wasn't John, it was invented by somebody else, but we're going to use it.
Who is the actual person that invented opal?
I don't know the name. It
Yeah.
was in the notes, but we're going to use a phosphorescent opal.
You just said the right word, opal.
Yeah. It's from a mine in California that I dug out of the mountain and then had it analyzed. And it was a very special opal. And you can see that the gray material on this opal is because we used it in a tumbler to get the material, the phosphorescent material out of it. And you can actually see the color of the opal is this white.
Right.
And when you put this opal underneath the black light, it shows up.
Even on this surface here?
Yes.
Wow.
And so this here, by the way, is calcium here.
Mm-hmm.
Sort of a chalk material.
So where's the opal?
The opal's right here. And we've broken some pieces off here.
Oh yeah, you can see the opalescence in it.
Mm-hmm. Yeah, when you get it just right underneath the light. So before I get all this all over my hands. Anyway, I sent Tom Bearden the stuff, and the next thing I know, I was talking to him night after night to where my phone bill went up to like $300-400 in a week. You know, so Tom was very interested in my work, and ever since that day, I've been good friends with Tom Bearden. And
That would have been when, early 80s, late 70s?
yeah, that was late 70s.
Yeah.
Just around 81, 82, 83, right around there.
Mm-hmm.
So let's get busy. The first thing I'm going to do is I want this pyrite material because of the different elements that are in it. So I'm going to put that down in here. And I'm just going to start grinding that up. See, round that up. That's all I need.
Okay.
No trickery there.
Right. And the next thing I'm going to do is I'm going to add a phosphorescent opal that I gathered myself after electrical tests because it's sensitive in a certain light band.
So how did you, just on the opal, you tested it in the ground or after you
No, I tested it after I brought it back home.
Oh, I see, okay.
And then I said, this will do.
So you got lucky? So
No, I didn't get lucky. I knew exactly where I was going because I had a map
Okay,
where the opals were.
Okay.
yeah.
And I had a portable blacklight with me, and I
Right.
knew exactly when I found it that it was sensitive to this a particular ray.
So no part of that opal was the calcium that you were talking about?
Oh no,
Yeah.
no. So now I've got the opal in there, and I've got.
The pyrite.
You see, I'm getting the powder that I want.
Oh, and you can see the opalescence in there?
Yes.
Yeah.
It's better. Yeah, it's good. Okay.
So anyway, what I'm going to do now is, I can't tell you the exact mix. I can tell you what I'm going to put in there because it's proprietary to Bedini Electronics in their sound crystal that they built for many years. So remember, we grew this material.
Mm-hmm.
So we know by the color of this material that it's high sulfur content, and we need a little bit of sulfur. So we're just going to add that in there, which is just what you see me do in the red. We're going to put that in the mix. different color.
That's good.
Okay, so now we've added our sulfur. We've added our iron pyrite. We've added our opal. And now what we're going to do is we're just going to take a little bit of the red powder that was grown from a different material. And we've added that in.
What do you mean red powder grown from a different material?
Well, this is grown from a proprietary material.
Okay.
Okay, in the
So-
same process that you
Yeah,
have.
same process that you see right here.
Okay.
Okay, so we're going to get that in there. We need all this base chemical mixed first.
Oh, yeah, it's definitely changing color. Secret sauce.
And yeah, and now we go for the meltable material. And we're actually going to add a little bit more of that because we need more.
How do you know the proportions, or are you just going to?
I'm just going to guess at it
Okay.
tonight.
I mean, in the real world.
In the real world, this will work.
There's a formula, huh?
Yes. And we're going to get this mixed up. And there's our mix. Okay, now what we're going to do is very carefully create our crystal here. So this is going to take steady time. And see, what I'm building is a path on the substrate. I'm going to send the signal from one signal. I'm going to send it into two signals.
This is what you will do once it's been fired, right?
Yes.
Yeah.
Once this is,
This is what your desired intent is, to send one signal. I mean, this is the reason you're doing this, is to send one signal from.
from one to two.
Right.
You know, I'm going to change the sound. In other words, I'm going to put a sound in. And I'm looking for a converter here. So geometrically, I'm doing a converter. I'm doing it very crude. But then, again, this is the way it's done. See, now I can put the signal in at the substrate, or I'll put the signal in at one dot. And what I'm actually doing here is I'm going to change the signals from what you would consider a mono signal to a stereo signal. And I'm going to let the crystal determine the frequencies. So how I'm going to do that is I'm just going to put one down here. Put one down here. And one down here. So now I'll just clean that up a little bit. Now, when the material drops on here, when it gets done,
That's what a ceramic.
yeah, that's a ceramic tile,
Okay.
and you can see the metals actually embedded in the tile.
So that's why you clean the tile off.
Mm-hmm.
Yeah.
I'm getting really hot. Let me just sit that in the center. Let's get the paper out of the way because... And you can see I'm now almost at 1000 C.
Oh.
So I'm about right in my temperature range to transmute what I want to transmute right now. So what I'm going to do is I'm going to open this. And that's hot. And of course,
dropped a lot.
sure, because I let it. I opened it, and then we're going to check it,
Okay.
and we can tell when it's fired when they settle down and it's
Okay.
melted into the substrate.
Do you time it or just?
Yeah, no, I'm going to visually do this one, but usually, yes, I did time it.
So does it matter how many you did, like a peace sign?
No, I could do as many.
As
I
many
just
little
wanted a
patterns as you
certain,
want.
so you could recognize the pattern on a round substrate.
Okay.
Otherwise, they would have done this on a square.
Okay.
But when you see the basic procedure of what nobody could ever figure out, you know, that had magical properties when you played music through it. So I'm going to keep my eye on this because this melts pretty quick.
And how can you tell when it's ready to come out?
Well, you'll be able to see that because the dots will actually melt into the...
Oh, so you're actually visually going to take
Yes,
a peek. Take a
yes.
peek. Yeah.
I'm visually going to watch it because I haven't done this in 18 years.
So what happens if you overcook it? The whole thing
If I
melts?
overcook it, it'll all melt. So, like I said, I wanted copper. I couldn't get any copper, so I'm just hoping that this works out correctly. And we'll know when we go to play it.
Yeah. What sort of success rate do you have on making these things?
Everyone,
Everyone, huh?
yeah, everyone works.
And everyone transmutes from one
Yeah,
one,
from one
met-
material to another. Like if you want to look in the oven right now
Well,
with your camera, you can look in there, but and you can see that it's changing right now because of the heat. So we're gonna go back up now.
Right. So what's the melting temperature? Is it about 1000 C?
Yeah. Yeah, right around in there, 1500. But it takes time to do it because it has to all be completely red when you look at it.
Even the substrate?
The
Must be
the
done.
substrate has to be red,
Uh-huh.
the dots are red, the whole crucible that I put it on here, this whole plate,
Right.
has to be red.
Okay. So does the little round plate, does that shrink in height or?
No, it's not going
It
to
just
shrink at
glows
all.
red,
It's
okay.
just going to glow red. I'm going to just take it up to red because then the materials are going to melt into the substrate.
Okay.
And that's exactly what's going to happen here. It's going to melt into the substrate.
So could you have used like thick copper sheeting or?
Yes.
Yeah. But you can't get that.
Yeah, I can fire up to...
Something
I
like this thickness maybe?
No, this is a little bit too thin.
Okay.
You need at least a 1/4 inch
Okay.
because you've got to be able to visually see where it is. So this will take maybe about close to a half hour.
Okay.
So you want to take a break, or?
Yeah. There's really no odor
smell.
to what it's doing. Okay, so we're going to take another visual look now. We're back at 1500 now. See, there we go. See, they're glowing.
Oh yeah.
So if you look very closely, it's melted into the substrate.
Yep.
Oh yeah.
Okay, so maybe about 2 more minutes. And we'll just take it out and we'll examine it. And if we have to do it over, we'll just do it over. It goes pretty quick all at once. The material lays down and fires. I've had them brittle. I've had them come out brittle. But I've never had one come out that didn't work if I put a dot there.
If you put it out there.
If I put a dot back on it
Oh.
and remelt it, then it works again.
Yeah.
So let's just see. I want it was pretty cherry red.
Yeah, it was.
Then it's going to come out red, and I'm going to try to get it on this heat sink right here.
The heat sink.
Yeah, see,
You
because
just pull the heat out of it.
yeah, just pull the heat out of it really quick. Back, when I was like 25 years old or 30 years old, I was much more coordinated with a pair of pliers going in and out of the oven. And it's a little bit tough now at 60. So let's see what we can get out of it.
Yeah.
Let's have a look. I think we're ready.
Good. It's like sliced tomato.
I'll actually turn this light off.
Go ahead.
Yeah.
You want to crack the lens?
And we're just going to let this cool off. We don't force it to cool.
Mm-hmm.
You can hear it. It's sort of
Clicking.
crackling.
Yeah.
And if you look here, see it's melted its way
Right.
into the substrate.
Right.
So the resistance path is already melted in. Look at this real quick and make sure these are...
Over easy or well done?
Well,
It's losing the heat rapidly now.
yes. Now, by the way, underneath the scale, you'll find all the minerals that were there. It's in the substrate now.
Oh, okay. Okay.
So if you sent that piece of metal in for an assay, it would come back with all the materials that were in it.
Okay.
And then they'd ask you where the mine was. So we've actually doped it.
So all the material's gone into the substrate.
Well, you can see it here. Come here. The material, see here? Here's the slag. See it?
Yeah.
Otherwise, it's melted into the substrate.
Yeah.
See, now when you get this, well, we'll
Yeah.
see as soon as it cools
Yeah.
to where we can file to solder. See, and it did crack the plate. See,
Oh, that, yeah.
Huh.
just cool a little bit too fast, but that's okay.
Are those pretty easy to buy? The
Yeah.
Are they special ceramic tiles for
Yeah.
that? Because they've got little feet
Yeah,
on
but
them.
sometimes you want to break them like this because you're only doing a crystal that's
Yeah.
smaller than this.
The little feet are designed to let airflow underneath.
Yes.
Yeah.
See, look.
Oh, yeah. Yeah.
hold
See,
on.
it's,
It's very red. I thought that was heat still.
no, that's ruby. See, copper's coming up, look. Remember when you were reading John Sajaka's notes, he said when the heat came along, the ruby comes from the copper.
Mm-hmm.
Where was the ruby? Where is the ruby? Yeah. Right.
Let's see if we can add a little bit of solder to that. Now we got a connection, see?
Mm-hmm.
Okay? Because we're going to put a wire there.
So are those things concave or convex or whatever?
Yes,
Okay. But they weren't like that to start with. were they?
right, they were not like that.
Yeah.
Which indicates something's fallen out of the bottom into the and being absorbed by the substrate.
Yeah. Now we just let it cool. And what we want to do after this is we'll peel some of the scale from the side and we'll examine it.
Okay.
And then we'll find out what materials are under there.
So the ruby came from what, the red powder or copper or the...
The ruby's a transmutation
Okay.
in the copper process under heating.
Okay.
And look here, you can see it. It's very red compared to what this is. See?
Yeah.
Extremely red.
Can you point out again the? So that is ruby powder.
That's ruby.
I mean, as in jewelry ruby,
Yes.
not just ruby
Right.
colored.
If it was a stone,
Right.
it would be bright red right now.
So you have that assayed, and that would actually be
Yeah.
ruby.
Mm-hmm.
So you could grind up a real ruby and get the same kind of powder?
You get a powder.
Yeah.
At least that's what the notes called it.
Mm-hmm.
So, but under examination, you'll find it underneath here in the material.
Yeah.
You might find something else too. Whatever it is, it's going to be an electrical conductive transmutation of this crystal here. See, this crystal is in 3 directions.
Right.
It's here. We'll wash it off so you can see it
Yeah.
better. We'll clean it off the best we can. But it's just the point of showing a different way of manufacturing a specialized item.
Mm-hmm.
You know, that deals with what you're working with at the time. You hear it popping?
Yeah, I did.
Okay, now it's breaking the scale list.
It's breaking the what?
The scale list.
Oh, it's okay. Yeah,
It's flaking off, see?
Yeah.
spalling.
Mm-hmm.
S-P-A-L-L.
Yeah, spalling.
See?
But it's not going to take off the other stuff that's...
No, this is... See how it's breaking off?
I heard that click too.
Okay, so this is very semiconductive when this breaks off. This red underneath there is probably light sensitive. Electric.
But the Y that you
Photoelect-
put in, it's sunk into the substrate.
Yeah, its photoelectric effect is probably what this is what it looks like to me from all the ones that I did. See how it's coming off here? Now if we look very carefully here when this comes off, see how it's transmuted the material? Look, starting to fall off. See?
Oh, yeah. That was the stuff I said looked like rosin or something.
Yeah.
When I asked you about it, yeah.
So that still looks like a copper substrate to me.
No, it's not. See, it wasn't that color in the beginning.
No, it wasn't. It looked more
If
brass-like.
you go get,
I'll get the other bit.
yeah, and then you can put the 2 there.
So what is that?
See,
Is that-
look here. This is where we're going to be able to tell what's in there.
Oh yeah. So is that gold?
Well, I'd have to get a magnifying glass to see, but it almost looks like it.
Yeah, see, that one was much
See?
more brass-like.
Yeah.
See, there's the material.
Yeah. Okay. Yeah. Just set it down there, and that's yeah. Definitely, there's definitely been a
A shift,
yeah.
an electrical shift. Remember that
So, John, this stuff you're flaking off, could that be retransmuted if it was ground up?
yes. I want to touch this. Yes. And we could do another one with that material added.
Is that very hot?
No. See, it's just... It looks like to me, Tony, that it's went photoelectric.
Meaning what?
That it's sensitive to light.
How can you tell that?
Because of the color, and you want to know something else? When you scratch it, it's got... When you scratch this, did you see what I did?
No, too deep.
Watch. It starts popping.
I heard it clicking, yeah.
Yeah. See, it just all of a sudden.
Yeah, the outside
See
part
the
of
gold,
it's just going
Tony?
to fall off.
See where the gold shows up?
Oh yeah.
Pretty good, huh? Where's the mine? See how it's just popping away? And this has got a bright yellow luster. This has a red luster. And look here as we get underneath it. See the luster? It's got like a gold sheen to it. See that? Look at that.
Woo!
There's the gold. See it? Yellow.
Yep.
Yeah. Glad I had glasses on.
Kind of interesting, isn't it?
So that's not the same color as this original guy.
No,
here.
no, this is new.
Yeah. That was great. I just had the camera on it and it popped off just when I was taking the shot.
There. You can see it there where I've scraped it. If I get it in the light.
Yeah,
Right?
no, I can see it.
It's jumping again.
Can you pick it up again? Just a little. Yep.
So do you have to take all that stuff off for it to be?
No, it'll come off by itself, but we're not concerned with that. We want it to play.
So, anyway, it appears the substrate has transmuted.
Yes, it
into
transmutes the materials under the heat.
And I guess the stuff on top of it has acted as some kind of a catalyst for that.
Yes,
to happen.
and see if you look very closely from this angle where I'm at, it's very gold where I scraped it.
Yeah.
Are you sure this is copper? It looks very brass to me.
No, it's not copper, it's beryllium.
Oh, okay.
See, look where I've scraped it. You can see with your eye.
Yeah.
See, it's not this color. It's yellow color.
Yeah.
So I guess you can all see why they said, where was the mine?
Right.
And this is what Sajeka was doing in a laboratory, and no one knows whether or not how he was getting his silver or his gold or any of this. But I know that when I figured out how to do it and make sound crystals that had conductive ruby and things like that, that he just had a fit.
Yeah.
He tried to stop this at all costs.
Because you reckon?
Yeah, because I did it, you know, and he didn't think that that would happen.
Oh,
But,
so you were too smart an apprentice.
well, I was a good apprentice. That's probably for the same reason why Sweet got rid of me, because I would have figured out what it was. And boy, that's really, come over here, Pat, where you can see it in the light. It's starting to really show up now.
Yeah.
See, because it has to grow. It's growing. Whether anybody wants to believe that or not, it's like a lizard getting rid of its scales, or a snake, right?
So as we're watching it, it's still transmuting.
It's still transmuting.
Is it radioactive?
No. I hope not.
Well, it would show up in the film if it was.
Yeah. Kat's a good apprentice. She'd make a good alchemist.
She would.
I like picking at things.
Okay. Just don't get burned. See where the base metal is, right? You got to understand that where the base metal is, that's what I put on here is this track.
Right.
Okay, but under the temperature, when the substrate heats and this starts to go in there, there's a diffusion process that takes place.
So if you just heated the substrate, nothing would happen.
No, it would just turn that color.
Right. What color?
It would just be this color, but it wouldn't have any of these things under it.
Right.
Because I've got them, I can pull them out of the box.
So what is all this stuff we're scraping off? That's
Just the slag.
The slag, okay.
And just to reiterate, the one on the left,
Is the metal.
yeah, and that is, and what is that metal?
That's Berlin copper.
Beryllium copper. Okay. What proportions? Do you know?
Oh, I don't know. It's just.
Standard.
Mm-hmm.
Yeah.
Whole lot's coming up here underneath, I think.
So how long will this transmutation process go on for?
Until it's cold. And it's obviously. See? There's the material in the brick.
Wow.
Went right to it.
Yeah.
And look at the layer. Look at this layer.
Yeah. So what would you say the slag consists of? All it's just whatever's left of all this stuff?
Yeah.
Yeah.
Just what the metal was. See, and it's.
Mm.
It's touchable. So what we got here is a hot piece of aluminum with all this slag. And it's like a vapor. It's like a fog when this stuff starts to fume. And it goes over the complete top of the base metal.
So you get a diffusion process.
Yes.
In the oven.
Mm-hmm.
So what's the stuff on the bottom again?
That was part of the brick.
The ceramic.
Oh,
the
okay.
ceramic.
Yeah.
Ceramic
Yeah.
melted into
Yeah.
it, see?
Okay. Got it.
But look here. See where the material wasn't?
Oh, yeah. Is that the same colour? Not quite. Yeah.
Hmm.
And we're going to go into the other room. So you're just going to have to follow us.
Oh.
I'm going to put one input wire in. Okay, so now what we're going to do is we're only going to use one channel of the amplifier, which is here. Sorry for the mess, but we're going to do this. Get the input here. So we'll just come out of the amplifier.
What was that noise?
Well, the amp was on, so
Oh.
It sounded good in the headset.
yeah.
Like a dentist drill.
So what I'm going to start out with is this. So this is the signal that I'm going to have. Sorry. Now, normally the amplifier would have thrown a hissy fit to do that. So, here we go. We're just going to use the left channel. We're going to go into the input of the chip. So basically, what we're doing there is we're using a one wire. I have to get a clip, so be. We're going to plug these into the amp. It's reactive. Hear it because the amp's off. We're going to come out of the other side of the chip here. See?
So what have you done?
So I've connected the only signal that we have, which was one signal.
Which was from that machine?
Yeah, yes. And what I'm going to do is I'm going to test the amp for no hum. Turn it up.
Okay.